qualitatively predicting reaction entropy. So you can look at a process and determine whether you think that process would result in an increase or a decrease in entropy. So, for example, if you have pure substances versus mixture, pure substances are much less disordered. A mixture is much more disordered. So pure substances will have a lower entropy than a mixture of substances. If you have any reactants in different states of matter, or if you're looking at a process like melting or boiling or freezing or whatever, remember a gas has got higher entropy than a liquid, and a liquid has got higher entropy or disorder than a solid. Okay, so if you're looking at a solid melting, that's going to be an increase in entropy. For any reaction that has gaseous reactants or products, whichever side of that reactant has more moles of gas is going to be in a higher state of entropy. If you have a soluble substance which dissolves into ions, well, if you have 1 mole of a solid, and even if it only is like monoatomic ions like sodium chloride, you have more ions when it dissolves, sodium ions and chloride ions, than the solid before it dissolves. So the side of the ions is going to have a higher entropy than just the solid. So let's see if we can apply that to these particular reactions here. So on the left-hand side, we have ions, and then they are coming together to form a precipitate. A solid, okay, precipitate. So the left-hand side of the reaction is more disordered, is in a higher state of entropy, and the right-hand side of the equation is more ordered, is in a lower state of entropy. So it's going from a high entropy state to a low entropy state, so that's going to be delta S is going to be negative. So we should check this box. Sign of our reaction entropy is going to be less than 0. So if you want to say higher S, lower S. There we go. All right, so let's look at the next one. Look at the states of matter very carefully. I instantly spot that one of our products in this reaction is a gas. So that means our solid zinc and our aqueous hydrochloric acid is going to be at a lower entropy. And then on the right-hand side, we got 1 mole of gas and, 3 moles of aqueous ion. So that's going to be higher entropy, more disordered. So we go from no moles of gas to 1 mole of gas. So definitely we're seeing more disorder on the right-hand side. So if we're going from a lower state to a higher state of entropy, then our entropy change is going to be positive. Okay, so going to check this one. Remember, entropy is a state function, so our change in entropy, actually I'll come back and just put a triangle, is going to be the final entropy minus the initial entropy, right? It's a state function, just like enthalpy, etc. Let's see if I can make a nice little that helps you out a little bit. Okay, so then the last one, we have carbon monoxide reacting with hydrogen to form ethanol. So what do we have here? Methanol even. So we got 1, 2, 3 moles of gas on the left-hand side, and only 1 mole of gas on the right-hand side. So that's going from a more disordered system with higher entropy on the left to a more ordered system with lower entropy on the right. So that is again going to correspond to a decrease in entropy over the course of the reaction. So delta S is going to be negative. Okay, so hopefully that is helpful.